exceptions. There's always exceptions in chemistry. It's one of the most annoying things, especially in this kind of way of separating these things out for properties. There are some covalent bonds that are really good conductors of heat and electricity, but that's more to do with a kind of like a very different kind of structure. For example, if you have like a huge network of carbon, the electrons can be pushed around pretty easily there. There's also these things called semiconductors, but we won't get into that. We're just going to kind of make these into very broad general categories here. And generally speaking, metallic bonds conduct heat and they conduct electricity really well. So on to the next property. I'm going to go down. And conducts electricity when dissolved in a liquid. What? That's weird. Conducts electricity when dissolved in a liquid. I'm just going to tell you what that is. That's going to be ionic bonds. Conducts electricity when dissolved. When dissolved. I'll just say when dissolved. Okay. So to understand this, you need to know that when you dissolve an ionic bond or an ionic lattice, is more likely, not just one bond here. When you dissolve that ionic lattice in, let's say, water, what you're doing is you're freeing these charged atoms. And those charged atoms are around where this atom over here is available to give off an electron, an extra electron, and this one's available to take up an extra electron. So when you stick wires into like a salt water solution, where the salt's been dissolved, the salt is an ionic bond, when it's been dissolved into water, what you're doing is you're, on one end of those wires, you're dumping extra electrons into the water, and these ionic atoms here, these ions, which is this atom right here that's ready to accept an extra electron because it's positively charged and it's already given away its electron, this atom right here can take in one of those electrons, and other atoms like it, the positively charged ones, they can take in those extra electrons, and on the other end of the wire, you can give away extra electrons from these atoms. So it's great because these atoms have extra electrons to give and these have extra space to fill in for electrons, and so it's as if you've got a wire going through the water, even though it's really just one end of the wire, you've got electrons that are being put onto these ions, and the other end of the wire, these ions are giving off electrons. So these conduct electricity through whatever liquid you've got if you've got ions in them. Okay? So that's why being in salt water in a lightning storm is much more dangerous than being in, let's say, like a lake in a lightning storm. Okay. Moving on. Right. Soluble. Soluble means dissolvable. So, which one of these dissolves in water? I often give a demonstration to show this, but it's just this one. So this is soluble. Nothing else dissolves in water. Water takes apart these atoms, and I'll show you a video of that right now. Excuse me. Water. Let's see, different tab. Water dissolving ionic compounds. Perfect. Let's see what we got here. Perfect. So here's a little video. Let's go to this part right here. Ah, great. So here you see a big lattice. This is what an ionic lattice looks like. You've got like over here, these would be like positively charged, and these would be negatively charged. The purple ones, the yellow ones are positively charged. And over here you see little water molecules. And they've drawn in little hydrogen bonds between them. You've got, that's a hydrogen right there in the green, and then the oxygen's blue. So let's see what happens. When you go, here you go, you got the red, that's the positive side, and you got the negative, which is the non-positive side. It's the negative side. It's a polar molecule. And over here, you've got the positive sodium ion and the negative chlorine ion. All right, so this is how water dissolves these lattices. So water comes in, and look at that. The positive side goes towards the negative ion, and they kind of like ferry it away and just take little tiny pieces of it away. And then they can take the positive side away. This attraction from the water is stronger than the attraction they have to each other. So they surround this. Look at the positive side is surrounding the negative ion, and the negative side is surrounding the positive ion. So they just gradually pull them away, and over time, it breaks apart the entire lattice. And so the entire ionic lattice structure breaks down, as you see right here. It's really cool. So it dissolves in water. Yippee. Right, next property. High melting point. So high melting point means that this is the point where the solid no longer is a solid anymore. So when you're looking at when you're looking at this, I don't want to start Skype. When you're looking at this, these structures, to become liquid, they need to be able to move much more freely. So a high melting point would be a structure that is not broken down very easily. So this has a high melting point. It's pretty strong and sturdy. It doesn't get broken down by energy being put into it. Melting point. And this is a high melting point. Well, it's actually not, sorry. We're going to say that it's not, but some of them, they can be high melting point. Right. And metallic bonds, that's variable. Some of them have a high melting point, some of them have a lower melting point. But we're just going to say ionic bonds, the ones that have the high melting point. Okay, moving on. Another melting point. Low melting point. This is the only property that we get to write for covalent. Low melting point. Now, why would that be? Why would this one have a low melting point? Why would it be easy to change this into a liquid? Well, the reason being is that if you put some energy into this, these atoms can pop apart just as they easily popped together to make this covalent bond. They are then changed into a liquid. If you think about this, I often give students examples of putting like sugar in a little bowl, and putting salt in a little bowl, and putting like a piece of metal in a little bowl. I guess you could also say metals have a lower melting point as well. Some of them have high melting points, but a lot of them have low melting points as well. Okay. So low melting point for covalent bonds. Low melting point for this, because if you put enough energy, these things move around enough that they'll become a liquid. Same thing here. Okay, so that's all my discussion of electrons and bonds and properties. Hopefully this makes sense how electrons, the structure of these atoms and their electrons, produces these properties here. So you should be thinking, okay, so these electrons, what they do determines what properties these overall bonds have. Okay, so you can see that there's a low melting point for covalent bonds. Everything else is mostly, everything else over here is related to ionic bonds or metallic bonds. Okay, so good luck with this, and it should be fairly easy. If you have any questions, let me know.